All right, strap in, everyone, because today we are going deep on something really kind of wild.
Yeah.
A computer that uses heat instead of trying to get rid of it. It's made by this company called Extropic,
Right.
and they are making some pretty bold claims.
Yeah, what's really fascinating is this idea they put forward
Yeah.
that this is how aliens would build computers.
Whoa, 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 hold on.
Like advanced civilizations.
Science, okay.
Yeah, it's all about like harnessing these natural forces of the universe,
What?
in this case, heat, to do the heavy lifting of computing.
Okay, you've got my attention.
Yeah.
So we've got a few sources that we're going to be using for this deep dive.
Okay.
Extropic has their own paper that lays out their vision for this thing.
Uh-huh.
We also have an interview with the founders where they get into some of the finer details.
Nice.
And then we've got like a more technical paper just to give us the scientific background on all this.
Perfect.
I am ready to unpack this.
Let's do it.
Where do we even start?
I think the best place to start is with the limitations of traditional computers,
Okay.
the ones we use every day that rely on these tiny little switches called transistors.
Right, like the ones in my phone and laptop.
Exactly.
Yeah.
They're great for a lot of things,
Yeah.
but they really hit a wall when it comes to artificial intelligence,
Mm.
especially anything that needs randomness.
Oh, interesting.
So think about all these tasks AI has to do, like generating these really realistic images or writing creative text.
Right.
This all thrives on randomness.
Right.
But the problem is our current computers have to burn a ton of energy just to create and then filter out random numbers.
It seems kind of counterintuitive, right? Like
Yeah.
trying to stay cool in the summer by running a heater and an AC at the same time.
Yeah, you got it.
Okay.
It's super inefficient,
Yeah.
and it's a problem that's only getting worse with these huge AI models coming out, like the ones behind these chatbots everyone's using.
Oh, absolutely.
The data centers are already huge energy hogs, and AI is just going to make that worse.
Okay, so our current computers are not really built for the demands of advanced AI.
It's a big problem.
So what about quantum computers?
Right.
Aren't they supposed to be the answer to like everything?
I mean, they definitely have a place, but they're not a silver bullet.
Right.
I mean, they're so expensive to build.
Yeah.
They need these extremely cold temperatures to operate. And honestly, the speedups they offer for like a lot of AI tasks are pretty limited.
Well-
It's kind of like using a rocket to deliver a pizza across town.
Right.
It's overkill.
So if traditional computers are struggling and quantum computers are a bit too much, what are our options?
That's where Extropic comes in with
Yeah.
our kind of radical approach.
I'm listening.
They're saying instead of fighting heat, why not embrace it as
Yeah.
a resource?
Interesting.
So their computer uses these things called p-bits. P-bits,
Okay.
which are inherently noisy, kind of
Yeah.
like bouncy balls, bouncing around on a tilted table.
Okay, I'm picturing bouncy balls.
Good.
But how does that compute anything?
So think about it this way.
Okay.
The computer takes a set of instructions as input.
Right.
It's like adjusting that table, the tilt of it, the shape of it,
Okay.
and the output is generated by observing where the bouncy balls end up after they like settle down.
So it's not about ones and zeros like a normal computer.
Well, it's not.
Okay.
It's all about probability.
Mm.
Their computer is designed to be probabilistic,
Right.
meaning it uses uncertainty to its advantage.
Okay.
And this is where their background in quantum computing kind of comes in.
Okay, so they're using similar technology to
Mhm.
build this.
It's
It still needs to
interesting.
be a physical machine, right?
Absolutely. They're using these things called superconducting circuits,
Okay.
which operate at these ultra-low temperatures,
Mhm.
and these things called Josephson junctions.
Okay.
So they've taken their knowledge from quantum computing and applied it to harnessing thermal noise.
Wow. Okay, so same building blocks, totally different game.
Exactly.
That's pretty mind-blowing.
Yeah.
But how do they make sure that this noise, this randomness, is actually useful
Yeah.
and not just pure chaos?
That's the trick, right?
Yeah.
They have to keep the noise significant but also controllable.
Right.
Like imagine you're trying to herd a bunch of hyperactive puppies.
Okay.
You want them to have some freedom to explore,
Why?
but they also need to generally go in the right direction.
Okay.
So it's a delicate balance,
Got it.
but their initial results are looking promising.
Okay. This is starting to make sense, but it's very complex.
Yeah.
So what makes Extropic's approach different from other attempts at this unconventional computing?
So one big difference is their focus on simplicity and scalability.
Okay.
They use this technique called sparsification.
Sparsification.
Yeah,
Oh.
to simplify the connections between these p-bits.
Is that anything like how our current computer chips are designed?
It's similar.
Okay.
The idea is by reducing the number of connections. Okay.
You avoid these bottlenecks and you allow for more efficient data flow.
Gotcha.
And they've also come up with this really cool thing called asynchronous updates.
Okay.
So instead of all these P bits updating at the same time,
All right.
like a synchronized dance routine,
Yeah.
each P bit updates at its own pace.
So it's more like a free-for-all dance party.
Exactly.
Okay.
And that makes things way faster and more efficient.
Okay, so Extropic is making some pretty bold claims about this being faster and more energy efficient than traditional computers.
Yeah.
Is that even possible at this stage?
I mean, they admit they're still early on.
Right.
Their current prototype is kind of like the Tesla Roadster of computers.
Okay.
Expensive,
Yeah.
not quite ready for mass production,
Right.
but it's a proof of concept.
Okay.
But the theory behind their approach suggests
Yeah.
it has the potential to be way more efficient
Okay.
because traditional computers waste so much energy trying to get rid of noise.
Right.
But Extropic's approach uses that noise.
As a resource?
Okay, so it's a fundamental shift in thinking.
Absolutely.
Okay, now things are getting really interesting.
Yeah.
What are some of the potential real-world applications for this?
Yeah.
Where could this kind of computer actually be useful?
So they're mainly targeting generative AI,
Okay.
particularly in areas where data is limited and there's a lot of uncertainty.
Hmm.
So think financial modeling,
Okay.
scientific research,
Uh-huh.
or even something like predicting the weather.
Wait, so you're saying this computer could help us make sense of things that we can't fully predict?
Exactly.
That's
That's
it.
wild.
Yeah, in these fields, you often have to make decisions with incomplete information.
Right.
And this computer could be used to create models that account for that uncertainty.
Mm.
Imagine a financial algorithm that could predict the market,
Yeah.
or a scientific model that can simulate climate change
Wow.
with way more accuracy.
The possibilities seem endless.
They do.
So instead of just giving yes or no answers,
It's giving a whole spectrum of possibilities.
exactly. And
Right.
while they're aiming to support the AI models that we already use,
Right.
they also imagine totally new algorithms that are specifically designed to work with their probabilistic computer.
So they're not just building a better mousetrap.
Nope.
They're inventing a whole new thing.
Exactly.
Okay, so are they alone in this space?
That's a good question.
Are there other companies doing similar things?
So there are other approaches to unconventional computing.
Okay,
Like you have neuromorphic computing, which aims to mimic the human brain.
I've heard of that.
Yeah.
But how does that compare to what Extropic is doing?
So there are some parallels, but neuromorphic computing often gets stuck trying to perfectly replicate the brain,
Okay.
which might not be the most efficient way to go.
Right.
Extropic is taking more of a first principles approach.
Okay.
They believe that as transistors continue to shrink,
Mm-hmm.
we're just naturally going to encounter more thermal noise, making probabilistic computing kind of unavoidable.
So they're not just trying to build a better computer.
Yeah.
They're trying to build the computer of the future.
That's the idea.
They're betting that harnessing this noise instead of fighting it
Yep.
is the key to AI.
That's right.
Oh.
They're confident that their approach will push the boundaries of computing way beyond what we thought was possible.
Wow.
Think about it. They're building beyond Moore's law.
Okay.
They're extending the limits of what computers can do.
Okay. I need a minute to process all of that.
It's a lot.
This thermodynamic computing is a lot to wrap my head around.
Yeah, it is.
But before my brain melts,
Yeah.
can we go back to these pivots for a second?
Sure.
They're clearly at the heart of all of this.
Absolutely.
Can we break down exactly how they work?
Of course. So remember our bouncy ball analogy?
Yeah.
Those bouncy balls represent electrons moving around in their superconducting circuit.
Okay.
And these circuits are super sensitive to heat
Uh-huh.
because they operate at these extremely low temperatures.
So it's like these electrons are tiny bouncy balls
Yeah,
being jostled around by heat.
exactly.
Yeah.
And the way those electrons move,
Yeah.
the paths they take,
Uh-huh.
that's what represents the probabilistic state of the cockpit.
Okay, but how do they control those bouncy balls, those electrons?
Right, it can't just be random.
Right.
So that's where this program of Blindscape comes in.
Okay.
They use these things called control voltages.
Control voltages.
Yeah.
Okay.
To adjust the energy landscape of the circuit.
So is that like adjusting the settings?
Think of it like tiny little dials
Okay.
that can tweak the terrain those bouncy balls are rolling on.
Gotcha.
By adjusting these dials, Extropic can nudge those electrons towards certain outcomes,
Okay.
making those outcomes more likely.
So they're tilting the playing field
Yes,
to
it
make
is so.
certain outcomes more likely.
Yeah,
Okay.
yeah.
But how do they translate those electron movements those bouncy ball positions into something meaningful, something that can actually be used for computation.
So that's where the observation part comes in.
Okay.
They use these amplifiers to measure the electrical signals coming from the circuit.
Okay.
Those signals tell them the state of the pivets.
So it's like taking snapshots of where those bouncy balls land
Exactly.
after they settle.
Yes.
Yes.
And by taking many snapshots over time,
Uh-huh.
they can build up a statistical picture
Okay.
of the probability distribution of the p-bits.
Oh, okay, that makes sense.
Yeah.
But it still sounds like there's a lot of back and forth between the p-bits and these traditional computers we talked about earlier.
Right.
Doesn't that kind of defeat the purpose of having this more efficient system?
That's a great point.
Yeah.
And Extropic knows it's a limitation.
Okay.
Their ultimate goal is to do as much of the computation as possible
Okay.
directly within the p-bit system.
So they want those p-bits to be able to handle more of the workload
Exactly.
on their own.
Yeah.
Okay. That would make the whole system more energy efficient and potentially even faster.
That sounds incredibly ambitious.
It is. Are there any limits to this technology? Are there types of problems that p-bits just aren't suited for?
That's something researchers are still figuring out.
Okay.
But it seems like p-bits excel at problems that involve a lot of uncertainty and randomness. So think about generative AI, where you're trying to create new data
Yeah.
that follows a certain probability distribution.
Okay.
It's like composing music or
Oh.
writing poetry
It-
or generating those realistic images.
Things that require creativity,
Exactly.
where traditional computers often struggle.
Yes, because they're so focused on rigid rules.
Right.
But for tasks that need really precise deterministic calculations like balancing your checkbook,
Right.
a traditional computer is probably still your best bet.
So it's not about replacing our computers entirely.
No.
It's about finding the right tool for the right job.
Exactly.
And it sounds like p-bits could be the perfect tool for unlocking the power of AI in these really exciting new ways.
That's the hope.
You mentioned earlier that Extropic is taking this first principles approach.
Yeah.
What does that actually mean?
So it means they're starting with the fundamental laws of physics and thermodynamics and building up from there.
Okay.
They're not trying to force their system to fit into existing computational models.
Yeah.
They're letting the physics kind of guide them.
So they're not trying to make a faster horse.
Oh.
They're trying to invent the car.
That's a good way to put it.
Speaking of completely different,
Yeah.
what about this whole alien computer thing?
Right.
You keep mentioning that this is how aliens would build computers.
Yeah.
Is that just like a marketing gimmick?
I mean, it might sound out there,
Yeah.
but there's actually some logic behind it.
Okay.
Extropic's approach is all about harnessing the natural forces of the universe.
Right.
And if you think about it, that's probably the most efficient way to build a computer.
Yeah.
Why fight against the laws of physics
Right.
when you can just work with them? An advanced civilization would probably figure that out pretty quickly.
It's like they're saying that aliens, being far more advanced, would have figured out that trying to control every aspect of computation is just a waste of energy.
Yeah,
It's better to let the universe do some of the work for you.
that's right.
That's a pretty profound idea.
It is.
It suggests that the future of computing might not be about building these ever more complex machines,
Right.
but about designing systems that work in harmony with the natural world.
That's the idea.
Okay, my mind is officially blown.
Good.
This is starting to feel like something out of science fiction,
I know, it's pretty cool.
but it's also incredibly exciting.
Yeah.
If Extropic is right,
Mm-hmm.
they could be on the verge of changing the way we think about computing forever.
It's a big deal.
Speaking of exploration,
Yeah.
I am curious about the practical side of all of this.
Okay.
How do you actually build a computer that uses heat as a resource?
Right.
What are the engineering challenges involved in creating something like this?
So that's where things get really interesting.
Okay.
Their prototype uses a combination of well-established and cutting-edge technologies.
Okay, like those Josephson junctions you mentioned earlier.
Exactly. They're a key component of these superconducting circuits,
Right.
which are essential for operating at these super low temperatures.
Yeah.
These circuits are incredibly sensitive,
Okay.
allowing them to detect the tiny fluctuations caused by that thermal noise.
But I imagine it's not easy to build these circuits,
It's not.
especially on a large scale.
It's a challenge.
Okay.
One of the biggest challenges they face is just fabrication. These superconducting circuits are so complex,
Yeah.
they require these state-of-the-art manufacturing techniques,
Okay.
and then you have the issue of shielding.
Okay.
They have to protect these circuits from any kind of external interference,
Yeah.
which is a big undertaking.
So it's not just about building it.
Right.
It's about keeping it running.
Exactly.
Okay, so there's definitely a reason we're not all using thermodynamic computers right now.
Yeah, we're a ways off.
It's a long road ahead for Extropic.
For sure.
But let's say they can overcome these challenges.
Okay.
Could this technology have implications beyond just AI?
Absolutely.
We talked about finance and research.
Yeah.
But where else could this lead?
I mean, any field that relies on probabilistic models could potentially benefit from this. Think about predicting things like weather patterns
Okay.
or earthquakes or even the spread of diseases.
Right.
These are all complex systems.
Yeah.
With tons of uncertainty.
Totally.
Traditional computers really struggle to model these things accurately.
It's like trying to predict the outcome of rolling 1,000 dice all at once.
You got it.
Way too many variables.
Yeah. Okay.
But a thermodynamic computer with its probabilistic nature could handle that complexity.
Really?
It wouldn't just give you a single prediction.
Okay.
It would give you a range of possibilities with probability
It's about understanding the full spectrum of what could happen.
instead of just the most likely outcome.
Exactly.
So instead of saying it's going to rain tomorrow,
Right.
it could say there's a 70% chance of rain, a 20% chance of clouds, and a 10% chance of sunshine.
Yeah, that's the idea.
Wow.
It's about embracing uncertainty
Right.
instead of just deterministic predictions.
I like that.
And who knows, maybe someday we'll be using these computers to model even more complex things like the human brain
Right.
or the global economy.
That is a huge leap.
It is.
But isn't there a risk that we'll become too reliant on these probabilistic predictions?
Yeah, that's a good point.
What if we start making decisions based on probabilities without actually understanding the factors involved?
That's a great question.
Yeah.
And it brings up some ethical concerns.
Right.
With any powerful technology we have to use it responsibly.
Of course.
Probabilistic models are great tools,
Sure.
but they're not a replacement for human judgment and critical thinking.
So it sounds like we need to be careful not to blindly trust the numbers,
Yeah,
even if they're coming from this fancy new computer.
absolutely. We have to understand the limits of these models.
Right.
And be aware of potential biases.
Okay.
Just because a computer gives you a probability
Yeah.
doesn't mean it's the absolute truth.
So it's about using these models as a guide, not a gospel.
Exactly. They can help us make better decisions,
Right.
but in the end, we need to use our own judgment and weigh the risks and benefits.
Okay, I'm starting to see how this technology could be both incredibly beneficial
Yeah,
and potentially challenging.
it is.
That's a double-edged sword.
I think that's a great way to put it.
Okay.
And that's what makes this whole topic so fascinating.
Yeah.
We're dealing with a technology that could totally change our world, but it also makes us think about how we use technology and how it impacts our lives.
It's a reminder that we're not just building machines.
Right.
We're shaping the future. Well said. Before we wrap up, I want to circle back to Extropic's claim about this being how aliens build computers.
Oh, yeah.
You mentioned there's logic to that. Can you elaborate?
Yeah.
What makes this approach so fundamentally different?
Sure. So it all comes down to efficiency.
Okay.
Traditional computers are essentially brute force machines. They rely on controlling every single detail of a computation,
Okay.
which takes a ton of energy
Sure.
and creates a lot of heat.
Yeah.
It's like trying to control every molecule in a gas to make it move in a certain direction.
Sounds exhausting.
It is, and that's why our computers are hitting a wall.
Oh, wait.
They're becoming really inefficient and unsustainable.
So Extropic is proposing a totally different approach.
They are.
Okay.
Instead of controlling every little thing, they're harnessing the randomness of the universe. They're letting the noise do some of the work.
Okay.
It's a much more elegant
Yes.
and efficient way of computing.
So less about forcing the computer to do what we want
Right.
and more about working with the natural flow of energy.
Exactly.
Okay.
That's why they think this is how a really advanced civilization would do it. They wouldn't waste energy fighting against the laws of physics.
Right.
They'd work with them.
That's a pretty humbling thought.
It is.
Maybe we have a lot to learn from these hypothetical aliens.
Maybe we do.
And maybe Extropic is on the right track to discovering those lessons.
Yeah, it's definitely a journey worth watching.
For sure.
Yeah, it really is a journey. It's like we're all in this together, right?
Totally.
But before we get too ahead of ourselves, talking about the future,
Yeah.
I'm still curious about, the nuts and bolts of this thing.
Right.
How do they actually build it?
Yeah. We've been talking about bouncy balls and puppies.
Yeah.
But what are the actual, materials and engineering challenges here?
So you know those Josephson junctions we talked about?
Uh-huh.
They are a crucial part of Extropic system.
Okay.
These tiny little devices are super sensitive.
Yeah.
They can actually detect like the tiniest fluctuations caused by heat.
So they're like these little heat sensors built right into the computer.
Exactly.
Uh-huh.
And they're housed in these super intricate superconducting circuits,
Right.
which are essential for operating at these extremely low temperatures.
So they're building a computer that needs to be super cooled
Yeah.
to function.
We're talking like colder than outer space.
But doesn't that seem kind of counterintuitive,
Yeah.
given that they're harnessing heat?
It does seem like a paradox.
Right.
The key is that they're not using heat from like the environment or anything.
Oh.
They're generating and controlling a very specific type of heat within the system itself.
Good though.
That's where those Josephson junctions come in.
Okay.
They can detect the subtle fluctuations caused by that controlled thermal noise.
I can't even imagine trying to build something that precise and delicate.
It's a challenge.
What are some of the hurdles that they're facing?
Well, one of the biggest is just fabrication.
Okay.
These superconducting circuits are so complex.
Right.
They require these super advanced manufacturing techniques.
Okay.
And then there's also this whole issue of shielding.
Okay.
You know, they have to protect these circuits from any kind of external interference.
Right. So it's not just about building it.
Yeah.
It's about keeping it running.
Exactly.
Okay. So there's definitely a reason that we're not all using thermodynamic computers right now.
Yeah. It's definitely a work in progress.
Long road ahead for Extropic.
Yeah. But let's say they can overcome these challenges.
Okay.
Could this technology have implications beyond AI?
Right. We've talked about finance and research.
Yeah.
But where else could this lead?
I mean, any field that uses probabilistic models
Oh.
could benefit from this.
Okay.
Think about trying to predict things like weather patterns
Okay.
or earthquakes
Uh-huh.
or even the spread of diseases.
Right.
All these super complex systems
Yeah.
with a ton of uncertainty.
Totally.
Traditional computers often struggle to model them accurately.
Right. It's like trying to predict the outcome of rolling 1,000 dice all at once.
Too many variables.
All right.
But a thermodynamic computer, with its probabilistic nature, could handle that complexity.
Wow. Okay.
It wouldn't just give you one prediction.
Right.
It would give you a range of possibilities with probabilities for each.
So it's about understanding all the potential outcomes,
Yes.
not just the most likely ones.
So instead of saying it's going to rain tomorrow,
Right.
it would say there's a 70% chance of rain, a 20% chance of clouds, 10% chance of sunshine.
Yeah, that's the idea.
Okay.
It's about embracing that uncertainty
I like that.
instead of just those deterministic predictions.
Right. And who knows, maybe someday we'll even be using these computers to model even more complex things,
Yeah,
like the human brain.
exactly. Or the global economy.
Wow, that's a big jump.
It is, but it's definitely a possibility.
But isn't there a risk that we become too reliant on these probabilistic predictions?
Yeah, that's a valid concern. What if we start making decisions based on probabilities without actually understanding the factors involved?
Yeah, it's a great question.
Yeah.
And it definitely brings up ethical considerations.
Right.
As with any powerful technology, we need to use it responsibly.
Of course.
Probabilistic models can be amazing tools,
Yeah.
but they're not a substitute for human judgment and critical thinking.
It sounds like we need to be careful not to blindly trust the numbers,
Absolutely.
even if they come from this fancy new computer.
We need to understand the limits of these models
Right.
and be aware of potential biases.
Mhm.
Just because a computer spits out a probability doesn't mean it's the absolute truth.
So it's about using these models as a guide, not a gospel.
Exactly. They can help us make more informed decisions,
Right.
but ultimately we need to use our own judgment
Clear,
and
yeah.
weigh the risks and benefits.
I'm starting to see how this technology could be both incredibly beneficial
Yeah,
and potentially challenging.
it's both.
It really is a double-edged sword.
Yeah, I think that's a great way to put it.
It's what makes this whole topic so fascinating.
Absolutely. We're dealing with a technology that could fundamentally change our world.
Right. But it also makes us think about how we use technology and how it impacts our lives.
Exactly. It's a reminder that we're not just building machines.
Right.
We're shaping the future.
We really are. Well said.
Hmm.
Before we wrap up, I want to go back to Extropic's claim about this being how aliens build computers.
Oh, yeah, the alien computers.
You mentioned there's some logic to that.
Uh-huh.
Can you kind of elaborate on that?
Sure.
What makes their approach so fundamentally different from how we've been building computers for decades?
So it all boils down to efficiency.
Okay.
Traditional computers are essentially brute force machines.
Hmm.
They rely on controlling every single detail of the computation,
Right.
which takes a lot of energy and
Really?
creates a ton of heat.
It does.
It's like trying to control every single molecule in a gas to make it move in a specific direction.
It sounds exhausting.
It is, and it's why our current computers are hitting their limits.
Okay.
They're becoming really inefficient and unsustainable.
So Extropic is proposing something different.
They're saying, instead of trying to control everything,
Right.
let's harness the randomness of the universe.
Okay.
Let the noise do some of the work for us.
So it's less about forcing the computer to do what we want
Yeah,
and more about working with that natural flow of energy.
precisely. And that's why they think this is how an advanced civilization would approach computing.
Hmm.
They wouldn't waste energy fighting against the laws of physics.
Right.
They would work with them.
It's a pretty humbling thought.
It is. Maybe we have a lot to learn from these hypothetical aliens.
Maybe we do, and maybe Extropic is on the right track to figuring some of that out.
It's a journey worth watching. Yeah, it really is. And it kind of makes you think about all the stuff we still don't know about the universe, right?
Absolutely.
Like, there's so much potential for new discoveries.
For sure.
Yeah.
So we've talked a lot about the benefits of this technology.
Yeah.
But are there any downsides or risks that we should be aware of?
That's a great question. I mean, any new technology is going to have its pitfalls, right?
Of course.
It's not all going to be perfect.
Right.
So one of the biggest challenges is just making sure this thing is accurate and reliable.
Okay.
Because with probabilistic computing,
Yeah.
you're working with probabilities, not absolutes.
Right.
So there's always a chance that the results might not be totally accurate.
So it's like getting a weather forecast that says there's a 60% chance of rain.
Exactly.
Oh, I want to bring an umbrella, but you can't be 100% sure.
Yeah, and that uncertainty can get even bigger when you're dealing with these really complex systems. So it's super important to develop really good error checking and validation techniques.
Right. To make sure the results are actually reliable.
Exactly.
So it sounds like we need to be careful not to over-rely on these predictions.
Yeah,
Especially when it comes to making important decisions.
absolutely. Human judgment and critical thinking are still super important.
Right. We need to understand the limits of these models.
Yes.
And use them as tools to inform our decisions, not to completely dictate them.
Totally. What about security risks?
Oh, yeah. Good point. Are there any concerns about hacking or data breaches with this kind of computing?
That's a really important area of research.
Oh,
Because these computers work so differently from our traditional computers.
right.
They might be vulnerable to all sorts of new attacks. So researchers are working on new security measures to protect these systems from hackers.
It sounds like we're really venturing into uncharted territory here,
We are.
which is exciting,
Yeah,
but also a little bit scary.
for sure. But that's how it always is with these groundbreaking technologies.
Right.
We need to be cautious and mindful of the risks,
Yeah,
but we also need to be open to the possibilities.
absolutely. Well, one thing's for sure, this thermodynamic computing is a fascinating development.
It really is.
It's changing how we think about computation
Uh-huh.
and opening up all these new avenues for innovation.
And it's a reminder that we're living in a time of crazy fast technological advancement.
Yeah, who knows what incredible breakthroughs are just around the corner.
It's exciting.
It really is, and that's what makes it so fun to explore these topics and share them with everyone.
I agree. And we always want to encourage everyone listening to really think about these advancements.
Absolutely.
And consider what they could mean for the world.
It's not just about understanding the technology itself.
Right.
It's about how it might change our lives and the world around us.
Well said.
So as we wrap up this deep dive into Extropic's thermodynamic computer, I want to leave everyone with this thought.
Okay.
We've explored a lot of complex ideas today,
We have.
but at the heart of it all, this technology is about harnessing the power of the universe. It's about working with the natural flow of energy instead of trying to fight against it.
It's a whole new way of thinking about computing.
It really is,
Yeah.
and it has the potential to unlock some incredible things. It's a reminder that sometimes the biggest breakthroughs come from embracing the unexpected,
Yeah.
from seeing potential in what others might just dismiss as noise.
And who knows, maybe this is just the beginning of a whole new era of computing.
Yeah.
One that's more efficient, more sustainable, and more in tune with the universe itself.
That's a really inspiring thought to end on.
I think so.
Thanks for joining us on this deep dive. We hope you learned something new and had some things to think about.
We did too.
As always, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.